Physics seminar. Today I am going to talk about force and laws of motion. The contents of these are definition of force, types of forces, inertia, introduction to Newton's laws of motion, Newton's first law of motion, momentum, Newton's second law of motion and Newton's third law of motion. First, let's know about the definition of force. There is actually no clear definition of force. Generally, we say that the push or pull of an object is called force. The push or pull of an object that makes movement or that changes the motion of the body is called as force. The force applied on the object to make a movement of it can be a contact force or non-contact force. When there is a movement or a motion of the body, then we can say that there is a force applied on the object. The force applied on the object can be a contact force. What do we mean by contact forces? The forces which are in direct contact with the objects are known as contact forces. For example, muscular force. With the help of hands, we can easily push or pull an object towards us or away from us. And the forces which are not in direct contact with the object are called non-contact forces. For example, gravitational force. Even if the gravitational force is not in direct contact with the object, the gravitational force can push or pull an object. So it is a kind of non-contact force. Force is a vector quantity. Force is a vector quantity because force has both magnitude and direction. In the next slide, we learn about the types of forces. There are mainly two types of forces. They are balanced force and unbalanced force. Firstly, let's learn about balanced force. Balanced force. If the resultant of all the forces acting on a body is zero, then the force is called balanced force. For example, if there is a force of 5 Newton from right to the left side and if there is a force of 5 Newton from the left to the right side, the forces will cancel each other and the resultant or the net force, which is the result, is equals to 0 Newton, which means there is no force acting on the body. So the object will not move. The forces acting on the object are balanced. So by this when the forces acting are balanced, we can tell that it is a balanced force. Now let's learn about unbalanced force. If the resultant of all the forces acting on a body is not equal to 0, then the force is called unbalanced force. For example, let's take there is a 10 Newton of force from the right to the left side and 5 Newton of force from left to the right side. When both the forces cancel each other, there will be 5 Newton left, that is moving from right to left side, which makes the object move from right to left side. The force acting on the object at that time will be 5 Newton. So when the resultant or the result of the forces acting on a body or an object is not equal to 0, then it is an unbalanced force. It means the forces acting on an object is not balanced. They are unbalanced forces. So 5 Newton towards left is not equal to 0. So by this we can say that it is an unbalanced force. By these balanced force and unbalanced forces, we can tell that balanced forces makes the object to be in the state of rest and unbalanced forces make the movement or changes the position of an object. Next, let's learn about inertia. The natural tendency of an object to resist a change in their state of rest or of uniform motion is called inertia. It is a natural tendency of any object to maintain and resist a change in their state of rest. If the object is in the state of rest, it will continue to be in the state of rest, and if the object is at uniform motion, it will continue to be at uniform motion. When this happens, it is called inertia. In simpler words, we can tell that inertia is also called as laziness. So let's take a football as an example. to describe about inertia. When we want a football to move towards us, even if we shout at it, it will never move. It will not make a movement. But when an external unbalanced force is acted on it, there will be a movement of the ball. By this, the object or the ball will move towards any direction or towards the direction where we want it to go. So it will continue to be at rest until an force is applied on it. So this law of inertia is also called as Newton's first law of motion. Now let's learn about Newton's first law of motion. An object continues to be in a state of rest or of uniform motion along a straight line unless it acted upon by an external unbalanced force. If an object is at rest, it will continue to be at rest, and if an object is in uniform motion, it will continue to be in uniform motion until an external unbalanced force act on it. Why should an external unbalanced force act on it? Because only unbalanced forces can cause movement, and balanced forces will make the object to be in the state of rest. For examples, moving of a car at uniform speed until the brakes are applied. If a car is moving with an uniform acceleration or uniform speed, when the brakes are applied, then the car will be stopped. So the brakes are the unbalanced forces acting on the car. So the formula for force is F is equals to ma, where F stands for force, m stands for mass, and a stands for acceleration. Force is equals to mass into acceleration. So the mass of the object is the measure of its inertia. Inertia of an object can be measured by its mass. So if the object has less mass, then it has less inertia, and if the object has more mass, it has more inertia. The SI unit of force is kg meter per second square. Next, let's learn about momentum. So what is a momentum and how does it come? How did it get its value? So force is directly proportional to mass. We all know that force is directly proportional to mass, and we also know that force is directly proportional to velocity, which means force is directly proportional to mass multiplied by velocity, which means the force is directly proportional to the product of mass and velocity. The force is directly proportional to the product of mass and velocity. By this we can tell that momentum is described as the product of mass and velocity. Therefore, it gets the formula P is equals to mv, where P is momentum. Momentum is represented by the letter P, and m stands for mass and v stands for velocity. As velocity is a vector quantity and a force is also a vector quantity, it makes the momentum also a vector quantity which has both magnitude and direction. The SI unit of momentum is kg meter per second. So now let's learn about Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the applied unbalanced force and takes place in the direction in which the force acts. So the rate of change of momentum of a body is directly proportional to the applied unbalanced force. So rate of change of momentum is also proportional to the unbalanced force, which means momentum is also proportional to the unbalanced force. And it also has F is equals to ma, and the SI unit is Newton or kg meter per second square. Now let's learn about Newton's third law of motion. Newton's third law of motion states that to every action there is an equal and opposite reaction, and they act on two different bodies. For example, if an object has an action or gives an action, then it will have an equal and opposite reaction, and the equal and opposite reaction will act on two different bodies. The Newton's third law of motion states it. For example, swimming and walking, etc. If we are walking, even while walking, Newton's third law of motion is applied. I hope everyone have understood the topics about inertia, force, Newton's laws of motion, and momentum. Thank you.